calculator. 30 years from now, it doesn't matter what you wore when you were in high school. I promise that. I only have 2 friends that I still talk to from high school. I only have 2 of them, so.
Yeah.
All right, so pull out your graphing calculator. Using the graphing calculator, we're going to graph this function and find the zeros. Because you can't factor it, doesn't have anything in common that we can pull out. We can't use factor by grouping. It's essentially unfactorable. So when that happens, the only thing we know how to do to find zeros or x-intercepts is to rely on our calculator. Today, we're going to learn how not to rely on the calculator so that we don't rely on it for everything. Because in the world of math, there has to be a solution for everything. Calculators didn't exist when math was created. So obviously there's a way around this, and we're going to learn that way around it today. But I want you to look up those zeros. When you look them up, you will have to zoom in probably once to see what's going on with that first peak, because it looks like it's a minimum that's touching the x-axis, and it just slightly goes over the x-axis. So you might have to zoom in to get a good sketch of the graph. But this is what it kind of should look like. I tried to graph this. But just that first one, it barely goes over the x-axis. So see if you can get those 3 zeros. So we know there's 3 because the power is x cubed. So that kind of is a reminder, hey, there should be 3 there as well. So it's not just accepting it.
Yeah.
Okay. Well.
At least that works.
Yes. So one of the zeros is really easy to find because it crosses over exactly at 2. Pierce, did you get a second 0? Say not that. Can I say that you have a second 0? 2/3. And how about a third one, Izzy? Anybody find the third one? Yeah, 1/2. So there are 3 of them, and you really do have to zoom in around this first part here, in between 0 and 1. So even if you change your window to be, the x values go from 0 to 1, you'll be able to zoom in. Here, I think you changed yours to get that, so that you can see that it does go over them. So these are the x-intercepts of the problem. 2, 2/3, and 1/2. Our goal today is going to be to try and find these without the aid of the calculator. The process of doing that is called long division. So just a refresher about long division. The divisor is what you're dividing by. That goes outside. So I'm going to divide by just a number 13. The dividend is what you're trying to break down. It's the bigger number. And we're going to try and break down that bigger number, or in our case, bigger equation. So we're going to pick a number here, 1432. The answer on top is the quotient. Just think about the process of dividing. You have 13. What are you supposed to do to break this down? Like, what are you thinking about? Autumn?
Aren't you supposed to see how many times 13 goes into 1, and then it doesn't, so you do 13 goes into 14 one time, so you put a 1 above the 4, and then you do...
1 above the 4. I went above the 3.
14.
Above the 4. And then you do, right, so you do 1 times 13, which is 13, and then she said you subtract those and you get 1, and then what do you do?
Then you bring down the 30.
And then you bring down the next number. Same thing. How many times does 13 go into 13? It goes in once. 1 times 13 is 13. You subtract, you bring down the next number. So 13 does not go into 2. So then that guy down there, what's that called? The decimal, the remainder. Remember about remainders? Usually we wrote remainders as like 2 over 13. The leftover after I was dividing with 13. So up here you would write plus 2 over 13. I know I'm going way back in your life.
Third grade.
Third grade, yes. Way back to third grade. But that was long division. So you had the 110, that's the number we broke down, with that extra remainder of 2 left over out of the 13. We're going to do that with functions. So we're going to see if we can break down functions. When we write our answers, and I'll write this one the same way, we're going to take the divisor. So in this case, I divided by 13. So my function, we'll always keep it as f of x, is equal to 13 times the quotient. Well, my quotient is the answer up there. So times 110, we'll put that in parentheses, plus the remainder, so plus 2. So what this is saying is what I originally started with, which is the 1432. I can find that by taking 13 times 110 and then adding that extra remainder back to it. So our answers are going to look like this. What I divided with, what I found to be my quotient, plus what any extra I have as the remainder. So let's see if we can look at the first problem. I've got a nice little setup so you have a visual aid as to where pieces are falling. It says divide 6x cubed minus 19x squared plus 16x minus 4 by x minus 2. So whatever I'm dividing by goes outside. Whatever I'm dividing into, or I want to break down, goes underneath. So the big piece should go underneath. So x minus 2 is outside, 6x cubed, 19x squared, 16x minus 4 is inside. This is the same problem you just looked up in your calculator. And that x minus 2 represents the 0 that we found in the calculator. Because remember, a 0 can be x equals 2, or it can be as a factor as x minus 2. Now, when you divide, Autumn said you saw how many times 13 went into 1. It didn't. So you saw how many times 13 went into 14. With algebra and polynomials, we're not using this minus 2. We're only using the first term. So if there were 3 terms with it, I'd still only use the first term. Because my goal is just to get rid of one term at a time. So I have an x. Here's my first term, 6x cubed. You need to ask yourself, what would you multiply x by to make it 6x cubed? So just the x. What would I multiply that by to make it 6x cubed? Anastasia? 6x squared. Since we said x squared, you're going to look over in your problem. Wherever you see x squared, that number goes above it. So 6x squared. Because x times 6x squared makes 6x cubed. Now, we need to multiply the number we pick on top by what we're dividing with. So on the side, I'm going to show that. I have 6x squared. I'm going to multiply that by x minus 2. Because you're going to get a quantity or an expression then. That's what goes in my purple box, my first purple box here. So I'm going to multiply this. I get 6x cubed and minus 12x squared. Your terms need to line up. We have to have like terms in order to combine. What do you do with division? What do you do with these terms? What's the next thing? Sally? Subtract them. Here's the thing you need to be careful with, because you're subtracting 2 things. This subtraction goes to both of them. So you're subtracting negative x squared, but you're also subtracting, you're subtracting 6x cubed, but you're also subtracting negative 12x squared. So this turns into a plus sign because a minus and a minus change to a plus. 6x cubed minus 6x cubed cancels. Our goal is to get that first term to cancel. And then negative 19 plus 12 leaves me with negative 7x squared. Now I bring down my next term, so I'm going to pull this down, 16x. And we're going to start the process over. Only looking at x. Now I'm trying to make it into a negative 7x squared. So ask yourself, what would you need to multiply it by, if you have an x, to make it negative 7x squared? And that would be a negative 7x. because I already have one x, so I need another one to make it x squared. And then if you need to do that scratch work on the side, I'm taking negative 7x times x minus 2. Big subtraction sign. Be really careful here because remember you're subtracting that entire quantity. So negative 7x squared minus a negative, that turns this into a plus so that they cancel. 16x minus 14x is 2x. And then we bring down 4. So step, I have an x, but I need to make it 2x. So it needs to be multiplied by 2. So 2 times x minus 2 is 2x minus 4. What's the remainder? Nothing. It's a 0. This being 0 is important because we found x equals 2 to be a 0. So this has to be a remainder of 0 to show that it is a 0. So this proves that x equals 2 is a 0, or an x-intercept. If it isn't 0, then it's not an x-intercept. So I have to have a remainder of 0 for it to be an x-intercept. So the last thing here, just to write my answer, because you do need to write your answer, you just can't keep it in this form. You take what you divided with, which was x minus 2. What I have as the answer on the top of my fraction, or my division bar there, 6x squared minus 7x plus 2. The remainder is 0, so you're not going to put plus 0 back there. Questions? So we could do the same thing with 1/2, we could do the same thing with 2/3, and we could work our way through it. So what I'd like you to do is flip the page. We're going to see if we can work through another one. It's the same exact problem again. But we're going to see what happens with this x plus 1. Is it a factor or is it a 0? How do I know? Why not? So we're dividing with x plus 1. 6x cubed, negative 19x squared, 16x minus 4. See if you can work through that problem. Just be careful when you're subtracting. You have to remember that that minus sign distributes to both of those terms. You're only looking at that first term, so the plus 1 does not change anything when you're trying to eliminate that first term. So ask yourself, I have an x, what do I need to multiply by to get rid of 6x cubed? Yes. Yep. So when I subtract, I have a negative 19x squared. Remember, I'm subtracting that 6x squared. So that means I have negative 25x squared. And I think that's the most common mistake to, forget about. Don't forget that goes through. It's a common mistake that I see. So hopefully you make it once and then you're done. Bring down the 16x. We have an x, but I need it to be negative 25x squared. So it needs a negative 25x. When I multiply, I get negative 25x squared minus 25x. And then again, big minus sign, so that turns both of them into pluses, because you're distributing that through. So those cancel, but 16 and 25 make 41x. And then we bring down the minus 4. I have an x, but I need a 41x, so I need that 41. Autumn, what did you have as your remainder? Negative 45. Awesome. So, Autumn, if I have a remainder of negative 45, was x plus 1 a factor? If there is a remainder, it's not a factor. Or it's not a 0. Remember, they mean the same thing. Factor, 0, x-intercept. So anytime there's a remainder, whatever you divided with isn't a factor, meaning it couldn't have been pulled out evenly. It's not a 0. So let's write this answer so that you know how to write one with a remainder. We take what we divided with, we divided that x plus 1. You take your answer at the top, the quotient, 6x squared minus 25x plus 41. And then the last thing is the remainder, and that is minus 45. So this is saying that I can FOIL these or multiply those two together. And then when I subtract 45, I'll go back to the original problem that I started with, my original function. So that's why we're writing the answer in this way, because they're equivalent. But you don't need to write the original function again, just keep it as f of x. Questions? It's fun, right? So let's try one more. We did x to the 5th plus 7 divided by x cubed minus 1. Yeah. Whatever's on the top is your bigger piece, x to the 5th. Notice how I have some extra white spaces here. In those white spaces, we're going to account for every power that is missing, because it jumps from x to the 5th to 7, whereas the previous one had all of the exponents, x cubed, x squared, x, and negative 4. So I'm going to account for all those exponents by putting in placeholders. So I'm just going to put a 0 with my exponents. So a 0 with x to the 4th, a 0 with x squared, a 0 with x cubed, and then x squared, a 0 with x, and then the last thing should be the constant. So that's the form of a polynomial. You've got all those powers descending in order. We're dividing with x cubed minus 1. So let's see if we can try this again. I have an x cubed. I'm ignoring the minus 1. Izzy, if you have an x cubed, what do we need to multiply by to make it x to the 5th? X squared. So I'm going to go to where I see x squared, put that with the x squared. And then we're taking x squared times x cubed minus 1. The reason I wanted to expand it is so that our like terms are kind of grouped together. So x cubed times x squared makes x to the 5th. X squared times negative 1 is a negative x squared. So x to the 5th minus x to the 5th is 1. I have a 0x squared. I'm subtracting a negative x squared. So this turns into a positive. 0 plus 1 makes x squared. And then I bring down my next thing, which is a 0x, and I start dividing again. I have x cubed. Is there anything I can multiply x cubed by to make it x squared?
X to the 1/3.
X to the 1/3. I'm going to keep whole number exponents. So we don't want to have negative exponents. We don't want to have fractional exponents, because then it wouldn't be a polynomial. So is there anything else? No. So when here, this exponent is bigger than my remainder, you're done with the problem. Don't forget the plus 7, because that's still part of it. But I can't break it down any further, because what I was dividing with is too big to break x squared down. So right here is the remainder. All I have is an x squared. We took that out. I'm going to put that in front since it's just a single term. I divided x cubed minus 1 into the problem, and then my remainder is x squared plus 7. So here is the remainder part in the back, my quotient, and then my divisor, what we divide for. Any questions? You don't have to, no. Kind of groups it together to show it's the remainder, but you don't have to. No. So when there isn't an exponent, make sure you look to put a placeholder in for that so that your like terms do end up grouping together. If it was a bigger problem, it would have made more of a difference, but this one was just a one step. But it definitely helps having those like terms kind of line up. So the homework tonight, I think there are 8 problems that you're going to use with this long division process. Have a great evening. See you tomorrow. 7 problems that are long division.